Hello all, welcome to the video lecture series for the subject operating system. Now I am going to explain you all about what is priority scheduling is doing with CPU actics. Like how does this CPU is really effective by using this priority scheduling. So here also we are going to check this algorithm with two different aspects of scheduling, that is primitive and non-primitive. So I hope you remember what is primitive. Primitive will always interrupt the process which is running inside a CPU if it has the highest priority or else the lowest burst time. Based on the priority, it will interrupt, right? So if it is non-primitive, the process will not leave the CPU unless it completes the task, right? So here, this is the example. Now this example covers the process ID, arrival time, burst time, and priority. PR stands for priority. This priority scheduling, how does it works? Like whenever the process is taken a CPU, it will be comparing the arrival time and the priority, not with the burst time, right? So the priority will be given for the process to execute based on the priority which is assigned already for each and every process. Let's take process 1 arrival times, 2, 3, 4 and 5. These are all the burst time. These are all the priorities. So here lowest priority value, that is highest priority, that is example 1. So 1 is the highest and the lowest is 4. Okay, I hope you understand. From this particular figure you can able to understand which is higher, which is lower, right? Now let's draw the Gantt chart. So this Gantt chart has been already drawn for the faster understanding for you. So here the Gantt chart has been drawn. Now always we need to look for which arrives first. Who arrives first here? P1. And what is the burst time? Let's forget about this burst time. What is the priority? Very low, but it is executing first. It is taking the CPU first because its arrival time is 0. No other process. How does the CPU knows that the process 2 is coming next, which is comparing, it will have a highest priority comparing to the process 1? Definitely not. CPU never know this because the arrival time is completely different. But process 1 arrives at 0. So now by the time 0, no other process has been arrived, right? So the CPU will give the first priority to this process. So here you can check it. Process 1 is coming inside and it is taking the CPU, and how long it runs, that's a point. So it runs for only 1 second. After this, by the time who is coming inside, process 2 is coming inside. Its arrival time is 1, right? So it is arriving at exactly at 1. And now we are going to check what is the priority comparing to this. This priority, process 1 is 4 and process 2 is 3. Which priority is high here? I already told you 1, 2, 3 and 4. This is the order. So the highest priority is 3. So comparing to 4. So process 2 comes inside. Okay, and what is the burst time? By the time when process 1 leaves the particular CPU, how long it was being executed? It is executed only 1 second. So the burst time will be reduced automatically. So it has to execute 4 seconds, but it is running for only 1 second. Why? Because P2 has been interrupted since it is a primitive scheduling, right? So by the time it leaves the CPU, again it is waiting in the ready queue. Now process 1 is going outside and burst time will be reduced into 3 because 4 minus already run 1. So 4 minus 1, 3. Now process 2 is coming inside and it is running for 1 second. After that is checking, P3 is coming and its priority is lower than which is already running inside. What is primitive? Whichever the priority is lower comparing to the process which is already running in the CPU will be interrupted, right? That's a point. That is primitive scheduling. So now this P3 is coming exactly at the arrival time as 2 and it is again running for only 1 second and it is completing its task. Now after that it is nothing left here because only 1 is the burst time here for this P3 and it is moving to the next process. By the time P4, 3 is coming. Arrival time is 3. So P4 is coming inside and it is taking the burst time and it can be interrupted because see here P3 is started exactly at 3. P4 is started exactly at 3. Sorry. So by the time you can check it, P3 P4 is started and it is taking the journey. By the time after it reaches 4, for example, after it reaches the timer 4, P4 is coming. Okay, now listen. Now definitely P5 has to interrupt this P4. It is not interrupting. Why? Because the priority for both this process have the same. Whichever process, now if both the priority is same, we need to check for which process id is low, 4 or 5. Which one is low? 4. So it is taking the cpu, that means it is starting at 3. We can check it is arrived. What is the bus time for this? For 3 plus 5, totally 8. I hope you understood this. This is the only major part you need to understand. Remaining part is very simple and calculation is also simple. So now the complete task has been over. This is also over. P3 is also over. Whichever is remaining here, P5 is remaining. It is the highest priority. P5 is coming at 4 already. So what is the bus time for this? Bus time is only 2. So highest priority P5 coming inside. Already P4 has been ended at 4. So 8 plus bus time for this P5 is 2. 8 plus 2 is 10. It is completing exactly at 10. So now which process is already, so this is also over, this is also over. We have two processes, that is P1 and P2. Now see here, P1 has been taken and it is run for only 1 minute, 1 second and 3 minutes left. 1 second and 3 seconds is left. P2 is completed 1 second, 2 seconds is left. Now check it. Among these two, which process has to come inside the CPU? Now again we are checking what? Priority. So 4 and 3. I told you lowest is high and highest is low, right? So based on 3 or 4, 3 is the highest priority. So that is the reason. You can check it. P2 is coming inside and it has to complete. The priority is very high comparatively. So P2 is coming inside. What is the time left for this P2? 2 seconds. So 10 plus 2 and it is completing the task. So 12 second, it exactly stops at 12. Again P1 is coming inside. Whichever is pending here, after that nobody is waiting. So whichever is pending here, what is the pending bus time? 3. So it exactly starts at 12. It ends by 15. So that is 12 plus 3, 15. So this is how the Gantt chart has been made. Now listen carefully. We need to draw the waiting time for each and every process to be successfully completing. So now what is the formula here? So we have formula called waiting time is equal to total waiting time minus execution time minus arrival time. So 1, 2 and 3 process we need to check. Let's check. Process 1. What is the total waiting time for this process 1? So you can predict. So initially it is waiting 0 and it is waiting here. You can check the maximum value you need to check. So process 1 is waiting for 12 seconds. You can check it. So process 1 waiting time is equal to 12 minus execution time. See here, before this process 1 is already executed. See, it has been executed in 2 time intervals. Number 1 here and number 2. So execution time before this process 1 is executed at the end, it was executed for 1 second. See here, 0 to 1. So that we need to mention over here. Number 1 and here. Minus arrival time. What is the arrival time for process 1? It is 0. I hope you understand how exactly it is happening. So P1 is equal to 12 minus 1 minus 0. The answer is 11. Right? So this is how this process 1, 2, 3, 4 and 5 works. You can able to check. This is the answer. You can able to check it, since it is a numerical subtraction. You can able to do that by yourself. And you can see the average waiting time is equal to, you are going to take all the answers. 0 plus 1 plus 0 plus 0 plus 4 is equal to 5 divided by 5 is equal to 0 units. So you are getting 0 units as an average waiting time. That means among all this particular scheduling, priority scheduling, that too primitive scheduling is much effective, because no process, that is average waiting for each and every process is, the average waiting time is, the unit is very, very, very less. Right? So this is the overview of this particular scheduling algorithm. You can check it once. I hope you understand the video. Thank you.